This video works through problem 8.4 from Gapenski's Healthcare Finance 6th edition. In 8.4, we're asked to go back to page 283 of your textbook to look at Exhibit 8.3, which is Carroll Clinic. And first we're asked to construct, and then we're given an actual results that are supposed to be used along with the static expectations that are outlined on page 283. So we have the information we have the P&L, if you look at section 4 of both Exhibit 8.3 and the section 4 of the data in problem 8.4. So that's what we're going to use to build the flex budget. So what I'm going to do is pause the video, write that out. I'm going to leave the flex column blank for a moment because we're going to fill that in. Okay, rather than handwrite this, because I started to write it down, it was a huge mess. So rather than handwriting this, I'm put it into Excel so you could see the P&L. So the data in the static column comes from page 283 of your text. So if you just go to 283 of your text and you look at part 4, the pro forma profit and loss statement, you'll see that I've copied the data out from that section. So that makes up the static portion of the P&L. And then the actual portion of the P&L comes from part 4 of problem 8.4 from the table in problem 8.4. So I've copied that out. So part A says for us to construct the flexible budget for 2015. So the first thing you want to do is copy out those two sections, set up a table that looks like this to work with, okay? And then we've got to calculate flex, right? So flex. So we've got all the information we need to calculate flex. But I'm gonna as we go, I'm gonna try to see if I can't maybe effectively toggle between Excel and handwritten information here, just because my handwriting I realize is poor, and maybe the visual quality of the video may not be perfect either. So we're going to see if we can't bounce back and forth here between the two. Okay, so let's remember. So you've got that. Let me stop the share for a second. So first line we're going to calculate is, and these are going to all be flex, right? So we want revenue, fee for service. Now, keep in mind that flex is price expected times volume actual. So what is our price expected for the fee for service? So if you go back to page 283, the expected price per visit is $25. The actual volume of fee-for-service, now we have to flip to the problem to page 8.4, and we find out that the actual volume is 34,000. So excuse me, 25 times 34,000 gives us 850,000 for fee-for-service revenue. Next, we want to know what our capitated our capitated flex revenue is. So we want, again, our expected price times our actual volume. So our expected, in this case, price is going to be PMPM, right? So it's per member per month. So we expect $3 per member per month. And then we're going to go to our, so that we get the $3, sorry, we get the $3 from $3 per member per month we get from Exhibit 8.3 on page 283. And then we go back to the problem and the table in 8.4, and we find that we have 30,000 members times 12 months. So we get 30,000 times 12 times 3, and we get 108000. Okay? So this is our expected price. This is our expected volume. This is our expected price. Sorry, this is our actual volume. So PE and VA. PE, VA. All right, let me toggle over to our spreadsheet. So we're going to put in for flex, we're going to put in 850. And then for capitated, we're going to put in 1080. And our total is just summing these two together. So we get 1930. Okay, now let's flip back to my handwriting. Now we need to work on variable costs. So we're going to work on expenses, variable for fee for service, and variable for our capitated patients. Now, here's a hint. It doesn't, if your expenses are driven by utilization by volume, right? And it doesn't matter how the patient pays for their visits, whether they are fee for service or capitated, the cost to provide a visit to a patient is the same regardless of what kind of insurance scheme is reimbursing the organization or paying the organization for the visit. So we just have to figure out what the variable cost per visit is. So we want our expected variable cost per visit. And if we go back to page 283, the expected variable cost is, if you go to section 3 on page 283, the variable cost per visit is 15. So we're going to use 15 for both capitated and fee-for-service patients, because it doesn't matter whether they are capitated patients or fee-for-service patients. Now that is our expected price. We need our volume actual. So we go back to to the problem and go to the table in 8.4, go down to volume, and we're going to see, so section 1 of the table in the problem 8.4, so on page 298, you can see that we actually had 34,000 fee-for-service visits, and then we actually had, a little further down, 43,200 visits for our capitated patients, for a total of 15 times 34,000 is $510,000. 15 times 43,200 is $648,000. So let me toggle over to our spreadsheet. Okay, so we're going to put for flex, variable expenses for our fee-for-service patients is going to be $510,000. Our variable expenses for our capitated patients is going to be $43,200. Sorry, 640. I'm counting the number. $648,000, and then we'll just sum that. So the total expenses for our flex, for our total variable expense, is $1,158,000. Now, we use for fixed expenses, we're going to use, because fixed costs are essentially just a price, we're going to use the fixed cost amount from the static budget. And that allows us now to basically complete this. So we said total costs then are the sum of fixed and variable costs. So we have 1,658,000, and profit therefore is our total revenue minus our total cost. And so there we have our flex budget for our P&L. So that is part A and part, well, and then now we have access to the data we need for part B. So let's see. I will copy that, some of that information down just so that it's easier for us to work with. So to finish off part B, now that we have the data, I've copied it out, just the highlights to work with. So we want to get profit variance, right? Because remember, we have profit variance decomposes into revenue variance and cost variance. And then revenue variance decomposes into price variance and volume variance. And cost variance decomposes into management variance and volume variance, right? So for this, for parts B, C, and D, this is what we're going to do. So we have everything we need to calculate that. So starting at the top with profit variance is going to be profit actual minus profit static, which is 49,000 minus 130,000. So to calculate that, 49,000 minus 130,000 gives us negative 81,000. So 81,000. So we were off in our profit estimate by 81,000. We thought we'd have a profit of 130. We actually had a profit of 49. So we were off by 81,000. So our profit variance is minus 81,000. So we put that at the top of our variance hierarchy. And we know that between revenue variance and cost variance, we have to come up with 81,000. Okay. Revenue variance is going to be revenue actual minus revenue static. So revenue actual is 1942 minus revenue static, which is 1980, or 1.98 million, which is equal to 1942 minus 1980, 38,000. So we're off. Our revenue estimate was off by 38. So revenue variance minus 38. I'm just going to 38K. Cost variance, I need a fresh piece of paper here. Is going to be cost static minus cost actual. So cost static was 1850 minus cost actual 1893 gives us 185023 minus 1893, 123, is minus 43,000. So if we take our minus 43,000 in cost variance, add our minus 38,000 in revenue variance, we get 81,000, which adds back up to our total profit variance. So minus 43,000. So minus 38 plus minus 43 equals 81. Minus 81, which matches our profit variance. So our decomposition is working so far. Okay. So that is part B. Part C asks us to now calculate the price and volume variance, to decompose revenue variance into the price and volume variance. So let me get another piece of paper. So if we want volume variance for revenue, we want to find the two columns that allow us to hold price constant but vary volume. So if you remember, static is price expected times volume expected. I'll just draw a line here. Flex is price expected times volume actual, and actual, of course, is price actual times volume actual. So the two columns that allow us to vary volume, right, and hold price constant are static and flex. So we're going to take our revenue flex minus our revenue static to get our volume variance for revenue. So revenue flex is 1930, and revenue static is 1980, 1.98 million. So 1930 minus 1980 is 50,000, a minus 50,000. And then our price variance for revenue is going to be where we hold our volume constant and vary our price. So flex and actual have the same volume but different prices. So we're going to use flex and actual. So we'll use revenue actual minus revenue flex. Revenue actual is 1942 minus flex 1930. 1942 minus 1930 gives us 12,000, a plus 12,000. So if we add, well, now we can go back to our table. Price variance then is 12,000, so 12K plus 12K. Volume variance is minus 50, so minus 50K. If we add these two together, plus 12 and minus 50, we get minus 38, which matches up to our parent variance, which in this case is the revenue variance. So we know we did this correctly, or at least we're close. So that is part C. Part D asks you to do the same for the cost side. So we already calculated the overall cost variance. So now we want volume variance for cost. And that is going to be where we keep price constant and vary volume. So that's going to be static and flex. And remember, we flipped the direction. So we're going to take cost static minus cost flex. So cost static, 1850 minus cost flex, 1658. 1850 minus 1658 gives us 192. So what does that tell us? Well, we had a decrease in volume and therefore had a decrease in an associated decrease in cost. And then we want our management variance, which is the price variance but applied to cost. And the idea here, we call it management variance because we think that the manager should be responsible for controlling the cost per unit of the things they use. So we're interested in comparing prices. So we want to find the two where we hold volume constant and vary price. So that's going to be our flex and our actual. So that's going to be cost flex minus cost actual. So cost flex is 1658 minus cost actual 1893. So 1658 minus 1893 gives us minus 235,000. So we were off by 235,000. So if we now go back to our cost hierarchy here, we came up with volume variance of 192 and management variance of 235, negative 235. So negative 235 plus 192 gives us negative 43, which matches up here. Right? So this is negative 43K, and that matches here. So we have done all of these correctly. Okay. Part E asks us now to decompose our management variance into three subordinate parts. So management variance, can I bring this over here? Management variance breaks down into, if you go to page, to get your information on this, go to page 293. Management variance breaks down into labor variance, fixed cost variance, and supply variance. Supply variance. Okay, so we're going to calculate these three now. And they should all add up to, they should explain the 235,000 and where it came from. Okay. So these are going to be involve a little more granularity, or generate a little more granularity. Let's start with the easiest one, which is fixed cost variance. If we flip back to our spreadsheet here for a second, fixed cost is basically a given price, right? It doesn't vary with volume, right? So the difference between static and flex is volume, but since there are no volume variant, there is no, by definition, fixed doesn't vary with volume. It's going to be identical. You're going to have 500 and 500 because this is price times volume. right? And we vary volume. Well, if volume has no impact on fixed cost, then the fixed cost will remain the same. And so then we have the actual fixed cost. So fixed cost variance is fixed cost um, flex minus fixed cost actual. Try to be consistent there. So fixed cost flex is 500 and fixed cost actual is 525. So fixed cost flex 500, fixed cost actual 525. We are minus 25,000. So our fixed cost, so 25,000 of our $235,000 excess expense comes from an increased amount of fixed costs that we did not anticipate. Next, we want to look at labor variance. Okay, so labor variance is going to equal labor costs flex minus labor cost actual. Okay, so we want for labor cost, we want volume actual times price expected, and then volume actual times price actual. So to get the easy part is to get the prices. So the price actual for labor, if you go to 8.4, the problem 8.4, and go to the part 3, the cost section, part A of the part 3 cost section, you'll see a line for labor, and it says 46,000 hours at $27 per hour. That is your actual labor cost per hour. So the price per hour you get for the actual labor cost was $27 an hour. The expected price per hour was $25 per hour. And you get that from going back to page 283, go down to cost assumptions, section 3A, labor, $25 per hour. Now we thought we would use, so part of the price, the way that we're working this out, part of the price is the number of hours per visit. So we're not attaching the number of hours per visit to the number of visits. We're making the price include both the price per hour and the number of hours per visit, and then the volume is strictly going to be the number of visits. So the amount of manpower per visit was estimated to be, was supposed to be 48,000 hours divided by an expected 90,000 visits. So that 90,000, so both of these numbers are coming from page 283. So the number of hours at $25 an hour comes from section 3, variable costs labor, if you look at that line, and then the hours per visit is the 48,000 hours from section 3, part A, divided by total expected visits, which was from section 1, part C, total expected visits. So this combined gives us our price. So this represents our expected price per visit. Over here, going back to 8.4, we have an expected an actual 46,000 hours of labor divided by an actual 77,200 visits. And then we take the volume actual, this is our price actual, versus our price expected. So it's a price per visit in terms of man hours, cost, man hour dollars. I guess that would be the right way to say it, man hour dollars. And so we take the volume actual from 8.4, and the volume actual from 8.4 is that 77,200. When you multiply that through, it's a bit of a mess, but when you don't really have to do the calculation here for the labor cost actual because it's given to you in section 3. I'm just kind of trying to show you the reasoning, but that comes straight out of section 3, part A, the labor line. That's 1242. 000. So if you did this multiplication, that's what you'd come out with. Over here, we get, this is approximately 0.533 times 25 times 77,200 gives us 1029,333. And so we add, if we subtract the 1242 from the 1029, we wind up with labor variance of negative 212,667. So so far we've got 212,000 from labor variance, negative 212,000 from labor variance, negative 25,000 from fixed cost variance. And then our last piece is going to be the supplies variance, which is a lot like the labor variance. So supplies variance, and supplies variance is going to be the supply flex minus supply actual. And again, it's going to have actual volume times expected price minus actual volume times actual price. And what we're trying to get in this, so we know the actual volume is 77,200 and 77,200. So those are the actual volumes. So what we need now is the number of units of supply per expected number of units of supply per visit times the expected cost per visit. So, and then over here for the actual, we'll take the actual cost of supply per unit times the number of units. So the actual utilization or number of units of supply per visit was, we had 90,000 units. Divided by 77,200 visits times a cost per unit of 140. So this is our actual price. This is our actual volume. To get the price per unit, the expected price per unit, we expected 150 per unit. We expected to have 100,000 units and 90,000 visits. So multiplying, and again, this is given to us in 8.4. So the total supply cost was 126. Over here, we do have to calculate. So we have 77,200 times 100,000 over 90. So 100,000 divided by 90, but not 100,000 divided by 90,000. is 1.11, repeating, times 150. So that times 150 times 77,200 gives us 128,667. So 128,667 minus 126 gives us 2,667 approximately. So our supplies variance is plus 2,267. So let's summarize this. Fixed cost variance was minus 25,000. Labor variance, we came up with 212,667. And then finally, supply variance of plus 2,667. Add that all together, and we wind up with minus 235,000, which equals our management variance. Whew, that's a lot of calculating. All right, so part F, interpret your results. All right. Other than it's a lot of work to do all that kind of number crunching, this is pretty complex. For my undergraduate course, obviously, I'm not going to have anybody do this, but it's useful to be able to drill down and understand where our problems in our organization are coming from. Kind of big picture, the clinic fell short 81,000. All right, going back, the clinic fell short 81,000 in profits. So let's go back to our kind of bigger picture hierarchy of outcomes. So we missed our profit target by 81,000. That can be explained by the fact that our revenues came in at 38,000 less than we thought they would, and our costs were 43,000 more than we thought they would. We could break our revenues down into price variance and volume variance. So we had a reduction in volume, and in fact, we expected to have 90,000 visits. We actually had 72,000 visits. That generates a decrease in revenue just strictly from volume. Price variance, we appear to have done a little bit better in terms of our price for the service we were rendering. Cost, on the cost side, again, we had a reduction in the volume, so we saw fewer patients. If we see fewer patients, we would expect to see our costs go down, which they did. So we had a positive volume variance, which simply comes from the fact that we saw fewer patients, so we spent less money from a volume perspective. However, that was swamped by the fact that we had negative management variance. And so we break the management variance down further, and we saw our management variance was off by that 235. 25,000 of it is explained by the fact that our fixed costs came in $25,000 higher than expected. Much more significantly was the fact that we spent more on labor than we expected to. And we had a minor offset from doing slightly better on managing our supply utilization. Let's see, any other key points? So it seems like kind of where's the biggest problem for this organization? You don't really see it, up front. If you look just at the profits and the revenues and costs, kind of, if you stopped here, there's not a lot of, there doesn't seem to be any big problem going on. It's only when you drill down to that next level that something really jumps out at you, and it's that management variance. It's quite large. Um, and you say, oh, we had a even though we had a big drop off in volume, we still spent a lot more than we thought we would. Where is that big um, overage coming from? And as it turns out, we're not doing a good job managing our labor. So that's the usefulness of this kind of exercise as you drill down, is to see where your problems actually are.